If n is a natural number and it is not a multiple of 3, then we need to show that the quantity 1 plus alpha to the power n plus alpha to the power 2n is equal to 0. Now we are given n to be a natural number, and also we are given that n is not a multiple of 3. Let's divide n by 3. We know the division, and we suppose we get the quotient q, and when we divide n by 3, obviously you will get remainder to be some remainder r. Then by division algorithm, we have dividend equal to divisor is 3 into quotient is q, plus remainder. Now since n is not a multiple of 3, remainder cannot be equal to 0, so it must be 1 or 2. Further, quotient can be 0 or 1, 2, 3, dot 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 dot. Now case 1, r equal to 1. That imply n equal to 3q plus 1, where q is again a natural number. Therefore, 1 plus alpha to the power n plus alpha to the power 2n equal to 1 plus alpha to the power 3q plus 1 plus alpha to the power 2 to the power 3q plus 1. What we have done, we just put n equal to 3q plus 1, and that's equal to 1 plus, by the law of indices, alpha cube to the power q into alpha plus alpha square. Again, we can apply law of indices, alpha cube whole thing to the power 2q plus 1. Sorry, it's plus 1 is the power, so that again alpha plus 2, that is alpha square. So 1 plus, but alpha being the cube root of infinity, alpha cube equal to 1. So 1 to the power q into alpha, again 1 to the power 2q into alpha square. However, 1 being a 1 to the power q being a natural number, 1, 2, 3, 4, or it may be a 0 as well, then we have that 1 to the power q is equal to 1, and 1 to the power 2q is also equal to 1. So we are just left out with 1 plus alpha square. Now again, alpha being a cube root of unity, we must have this equal to 0. Well done. So case 1 we are done if a remainder equal to 1. Case 2, if remainder equal to 1, then we have shown that 1 plus alpha to the power n plus alpha to the power 2n equal to 1. Now case 2, r equal to 2. Then again n equal to 3q plus 2. That is simply by division algorithm. Therefore, 1 plus alpha to the power n plus alpha to the power 2n equal to 1 plus alpha to the power 3q plus 2 plus alpha to the power 2 times 3q plus 2. Again, by law of indices, that is equal to 1 plus alpha cube to the power q into alpha square plus alpha cube to the power 2q into alpha to the power 4. 2 into 2 equal to 4. Okay, that's again by law of indices. Again, alpha cube equal to 1 and 1 to the power q equal to 1. So this is 1 into alpha square. Here also alpha cube equal to 1 and 1 to the power 2q equal to 1. So you have 1 into alpha to the power 4. That's equal to 1 plus alpha square. Alpha to the power 4 can be written as alpha cube into alpha. Again, alpha cube equal to 1. So everything can be arranged into and written as 1 plus alpha square. That is again 0. So we have in both case 1 and case 2 that 1 plus alpha square equal to 1 plus both in case 1 and case 2 we have 1 plus alpha to the power 2n plus alpha to the power n equal to 0. Of course, this is not true if if n is a multiple of 3 or if n leaves the remainder 0. In that case, okay, just additionally, if n is a multiple of 3, that's not part of the question, but we can answer that as well. If n is not a multiple of 3, if n is not a multiple, n is a multiple of 3 this time. If it's not a multiple of 3, we have already done. If n is a multiple of 3, if n is a multiple of 3, then we have 1 plus n being multiple of 3, this will be also 1, this is also 1, equal to 1 plus alpha to the power n plus alpha to the power 2n. That is 1 plus alpha to the power n plus alpha to the power 2n is equal to 3. So in this case we get it to be 3, not 0.